Hi, I've clicked onto today's tropical tidbit for Thursday. It's day 2 of the hurricane season, and we still have two areas of disturbed weather in the Atlantic to keep an eye on. The first over here is 93L. Moving southwestward over the Gulf of Mexico, you can see it's kind of losing its convection. There's a little bit of a surface circulation evident here, but it's continuing to move southwest. And although the BAM models continue to insist that it will curve into Texas, I think it's going to just follow the ridge and stay a little bit farther south than that. It may end up in Mexico if it doesn't dissipate before then, though South Texas can hope for some of these showers to reach their arms over here and try to give them some rain in these drought-stricken areas. But this is weakening. The NHC gives it near 0%, and I agree this is not going to develop anymore. It had its chance. It was a good run, a great little mesoscale convective complex system that is interesting to see once in a while. Brought some rain to Florida. Good things came from this. Our second area of disturbed weather is down here in the Caribbean. Notice this big area of convection mostly off here to the northeast now. Notice that there's nothing over here, though you can see a residual broad circulation still northeast of Nicaragua over here that hasn't really moved a whole lot, but all the convection is off here. There is a secondary vorticity maximum developing in the low levels over here southeast of Jamaica in response to a tropical wave that is embedded in here somewhere, likely about to get diffused and absorbed into the broad low pressure, but there is convergence going on strongly over here. If we look at the water vapor imagery, you can see how the jet stream is outlined, the subtropical jet stream. Notice how it's bulging north over here. All the release of heat in this area is causing the ridging to balloon up in here. Here's that upper low over the Gulf of Mexico, and this is backing west-southwest, and as it does so, it's allowing this ridge to pump up in here. You can see that the wind shear has finally started to lower a great deal in here. Here's the jet stream to the north. Notice that we have an area of less than 10 knots of wind shear developing over the southwest Caribbean and less than 30 knots all the way up to Jamaica now. And this is going to continue to lower in here and eventually expand, providing more favorable conditions than the system has had over the last few days. Going back to the satellite, notice how this upper low is in here and it's going to continue to back this way. Eventually this bulge is going to be able to balloon up further to the northwest in here, making conditions favorable for this area of the Caribbean than they currently are farther west. It's also interesting to note, if we turn on the high level winds, here's where the axis of the trough is according to the satellite analysis. According to the models, this trough axis was supposed to be way back here over the central Gulf this morning, not all the way down near close to the coast of the Yucatan. It's interesting to surmise that perhaps all the heat that was released from the thunderstorms associated with 93L has pressed down on this cold pocket of air. Remember, upper lows aloft indicate cold air. Convection indicates warming air aloft, and thus this could have pushed this a little bit farther south than the models had it, because remember, none of the models really saw this. I haven't seen a model really show the convection from this system over the northeast Gulf of Mexico. It's interesting to think that it could have shoved this a little bit farther south. It'll be interesting to see how that affects the forecast, if at all. Generally, when an upper low is forced further southwest, the further southwest it is compared to the system that it's ventilating, the better for the tropical system. So we'll see how this works. But in a couple days, this upper low is supposed to kind of curve up over here after backing further west-southwest. And either way, I think it's still going to provide a fairly decent environment within 2 to 3 days for this area in the Caribbean. Now, this area, if we're going to get this to develop, this area, of course, is going to have to be brought in back toward this main area of low pressure. A couple of days ago, I showed you how the models were bringing this, what's here now, out of South America, which they did. They brought moisture out of South America associated with the tropical wave that came westward, and that's what's giving us this right now. A lot of the models completely tore the system apart by using this Fort Max to bring all the energy out to the northeast into the trough that's going to be diving into the western Atlantic and cause the system to die, leaving nothing behind in here. I still think it's going to hold on to this piece of energy. It's not going to go anywhere. It's just displaced right now. To bring that back in, a couple of things are going to have to happen. First of all, as this trough in here eventually splits off with this upper low moving this way, that's going to cut the flow, which is currently out of the south in this area, and make it back from the east-southeast as this ridge builds in here, eventually steering this back this way within a couple of days. But there's another thing that's going to aid this. Is notice the bulge in the cirrus clouds is currently right here. As this upper low continues to move this way, that bulge is going to migrate west, and as this trough dives down into the western Atlantic, it's going to squish the winds right here, making them more out of the northwest, and that's going to change the areas of upper divergence here. If we look at the GFS 200 millibar, 84 hours, notice that trough here again that's diving into the western Atlantic. Notice what it does to the upper winds here. They're out of the northwest now in this area. This is a confluent zone right in here. This is now a confluent zone. Right now it's a divergent zone, which is why we have all the convection going off in here, because the winds are divergent. Once they become confluent, that means air is piling up aloft. When air piles up aloft, it's forced to sink downwards toward the ground, and sinking air is not conducive for thunderstorm activity. Notice that the upper low is back here over the northwest Gulf of Mexico, and here's the bulge in the subtropical jet stream indicating the upper ridging aloft. This is a defluent environment, which means that air is spreading out aloft, which forces air to rise upward from the ground, supporting thunderstorm activity. So we would think that the area of precipitation and convection that's currently over here would want to migrate further west in here, perhaps getting more in line with the broad area of surface low pressure that is down here. Now today I want to show you the NAM model, and normally I won't do this because the NAM model is not very good for tropical cyclone development. However, there's something very cool about having a convective feedback model in your backpack, because it can be useful for many things. One thing is that when you're forecasting broad systems developing in the southwest Atlantic, if you don't have the convective feedback models, in other words the NAM and the Canadian, if you don't have them on your side for development, then there's something wrong, because they're going to show development in almost every situation that is possible for them. So if you don't have them on board, then there's an issue. But more than that, the NAM, I find, initializes and forecasts the main areas of convection, the mesoscale processes fairly well, and I like the resolution of this model, as it can help out in many ways. This is 24 hours. Notice how the batch of precipitation currently, it's all back here, southeast Jamaica. Notice that by 24 hours it starts to migrate a little bit farther west. Here's the broad area of low pressure east of Nicaragua. If we go out to 48 hours, you can see that it's a little bit farther west in here, and the broad low is starting to move a little bit farther north. And then by 72 hours, notice the precipitation comes all the way back into the northwest Caribbean, in line with the upper level winds we were talking about in here. And the evidence that we showed here is showing up on the NAM. The precipitation comes farther west, the broad low starts to come north, and it starts to deepen a little bit because everything is starting to consolidate a little bit more in here. And this is interesting because it makes sense given the meteorology, and it also shows that, again, the system is broad, it's June, it's going to take a long time for this thing to get together. It's going to take a while. Probably by this weekend we'll start to get the upper level winds more favorable in here that will allow this to try to consolidate if it's going to. There's no guarantee that this will develop. The only models that still develop it this morning are currently the UK Met and the Canadian models. The GFS has dropped off. The European leaves a broad low down here to sit for all 10 days of the model run without developing. None of the other models really have this developing. I still think it has a chance, given that upper level winds will be favorable if it can reel this in here. This is the key right here, is if it can reel in this vortex, bring it across like the NAM shows and like the upper level pattern would support, then this may have a chance down the road. But for now, nothing to be too concerned about, just watching it for some rainfall. We've got several days to watch this thing. A 93L is not developing and is heading out this way. South Texas can hope for some rain. But we've got a lot of activity going on here for the first couple days of the season. It's interesting to watch. We'll continue to monitor it into next week. Alright, that's it for today. Thanks for watching.